Okay, number 1. So I'm going to use the formula y2 minus y1 over x2 minus x1, right? That's what I'm doing. That's slope. Rise, the difference in the heights. Run, the difference in the x's. So the second y is going to be the coordinate that is x plus some h away. So whenever I see an x, instead of x, the value is actually x plus a little bit. So that's the y2. And then the y1 is just your original output. And then your x2, again, is that x value that's a little bit away, minus your original x. And then the point of this is to say what's happening as that space between the x values gets to 0. Okay, so do you remember what we did yesterday? It was all algebra stuff. I need you to think of this squared, and then you're still going to times it by 4. So you're going to have to square that. Okay, so you saw me square it. I times it by 4. Now, 4x squared, gone. Okay, out of what's left here, what did we want to do with that? Do you remember the next algebraic step? GCF, take an h out. Because obviously the whole time the problem was I couldn't input h, right? Because then it would create that divide by 0, which is never what we want. So with all that algebra, I got rid of the problem. So once I get rid of the problem, now I can say, let's input the 0. So the result would be the equation 8x. So for instance, at the x value 1, it would have a slope of 8, that tangent line. At the x value of 2, the slope would be 16. So my question was, what is the slope specifically at the x value of 5? So specifically when you are exactly at a tangent line at 5, you would have a slope of 40. Probably not. Okay, I will help you cube this, and then I'll let you finish it though. Okay. Because we know we're going to have to do this for our y2, right? This is what our y2 would look like. Paul, oh, you guys know how to do this. What is your tree? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. You know how to do this. Okay, so it should be 1x cubed plus 3 what? What do you do with the x squared with an h plus 3 xh squared. Do you remember doing this? Did you see how my exponents are going down on x and up on h? Okay? So there's my hint for that one. And then I will let you finish that. So you have to do that, and then you're going to do minus the original, 5x cubed, all over. Okay? So there's my hint for foiling it out. I'll let you finish that. Answer first or after? We'll check it after. How about? Okay, so this is the other type you're going to get, which is a fraction. Okay, so the limit when h approaches 0, y2, so 24 over x plus h, right? The function, make sure you, instead of putting x, you put x plus h there, minus the original, all over x2 minus x1. Okay, what should we do to put two fractions together? Common denominator. So on that, I'm going to have to write the unit x plus h and the unit x to put them together, right? I need both of those things in my denominator. Okay, first fraction, what would I have to multiply it by to turn the denominator into that? X. So 24x. Then this fraction, this would have to get multiplied by x plus h. Right? Everyone's with me so far? All over h yet. Okay, do we see what happens? 24x minus 24x. If you're okay, I'm going to rewrite it like this. Instead of dividing by h, I'm just going to flip multiply. Okay, now there's somewhere that's always going to get your problem out, right? Some h is always going to cancel. Okay, I'm done writing limit. Did you notice I wrote limit always in front until I'm literally ready to plug it in? I'm ready to plug it in now. So if I put h in, so I'm just going to cover h of 0, what's the bottom going to be? X squared, right? So if there's no h there, it's just x times x. And that's your equation. Okay, I don't think I asked you anything specific. I just said the general slope equation. But sometimes I might say, what is the slope at da-da-da? Okay, shortcut. Should we see if we did it right? Here is our original. Can you think of another way to write that? What do we know about stuff on bottoms? Yeah, x to the negative 1. Right? That's just a different way to write it. Okay. times, what do you get? Negative 24, and then go down. Times, and then go down. Does it match our answer? That's our slope equation. Anywhere you want to do a tangent line, that's your slope. Okay. And you're going to have a radical type. So I'm going to have 3 types. We just did a polynomial type, a fraction type, and this is a radical type. Okay, so limit as x approaches 0. y2 is the function using the input x plus h. y2 is the original output. Over x2 minus x1. Okay, now I don't really want to have radicals right now. What was the one math tool we used to get rid of radicals? And it was a really weird word. Started with a C. We usually did it when the radicals were on the bottom, and I said, well, how do we get rid of the radicals on the bottom? Multiply by, what's the C word? Remember that word? The conjugate? Does that ring a bell? So what is the conjugate? 18 root x plus h plus, do you remember something that looked like that now? Basically, it's the same concept as a difference of squares, right? Okay, so let's work to simplify the top. Okay, what happens here? So what's out front? What's our new number? Anybody know 18 squared? So I was going to put it in your calculator though. 18 squared. Is it 324?
It is 324.
That was just a random guess. 324. What happens when I do a root times its same root? It just becomes its underneath part. Cancels. Are you remembering when I FOIL that I don't have to do that part? I can shortcut the FOIL and just do flow, right? Cancel. And then this is always subtract 324, and then the radical part cancels. On the bottom, obviously you saw that I took those x's out, but otherwise I'm not going to do anything with it. I'm just going to leave it like that. Okay, so this makes 324x plus 324h. Okay, Then, have you noticed a pattern? Once you're algebraically maneuvering, something on the top usually disappears because there's something minus something of the same. Okay, same pattern. Guess what's going to happen now? An h will cancel. And as soon as you're done canceling that h, you're now ready to apply the limit stuff. So I can plug in 0 now. So what do you get if there was no h on that spot? So it would be 18 root x plus another 18 root x, making 36 root x. I'm really guessing that those numbers probably reduce, right?
Actually, where does the h go that's in the...
Yeah.
This,
Oh, it's
I plugged in, that was my plug-in,
Oh.
right?
That makes
So
sense.
now you say if the h was 0 at that point. Okay? As soon as you cancel that h out, that's always when you can do your, okay, now the limit. So do you see how I stopped writing limit at that point in front? Did we check it with the cheat, the shortcut?
I can't look at this one.
Okay, 18 square root x. Tell me a different way,
Yeah.
you know this from the logs exponent unit. How do you write root, square root, differently? A half. So then what happens when you do 18 times a half? 9. And if you are at a half and go down, now you're at negative a half, which is the same as that, right?